Here's a theoretical concept about nebula, the stellar nurture hypothesis. Nebula, often regarded as the stellar nurseries of the universe, have long fascinated astronomers due to their role in the formation of stars. The traditional understanding is that nebula are massive clouds of gas and dust that collapse under gravity to give birth to new stars. However, the stellar nurture hypothesis proposes a more intricate perspective on these celestial objects. 1. Nebula as cosmic catalysts. Nebula are not just passive containers of star-forming material. Instead, they actively participate in the formation and evolution of stars. The hypothesis suggests that nebulae act as cosmic catalysts, orchestrating the birth, growth, and death of stars within their confines. 2. Nebula feedback loops. Nebula are dynamic, evolving structures influenced by various factors like radiation from existing stars, supernova explosions, and the magnetic fields present within them. These interactions create feedback loops that influence star formation. For instance, intense radiation from massive stars within a nebula can compress nearby regions, triggering new star formation while simultaneously dispersing material from other areas. 3. Nebula ecology. Nebula should be considered as complex ecosystems with their own food chains. Gas and dust within nebulae form the basic building blocks for star formation, akin to nutrients in an ecosystem. Protostars, young stars, and massive stars play the roles of primary, secondary, and apex consumers in this nebular food chain. 4. Nebula evolution. Nebula have life cycles just like stars. As stars form and evolve, they influence the nebula from which they emerged. The remnants of dead or dying stars, such as supernova remnants, can enrich the nebula with heavy elements impacting the composition of future generations of stars. 5. Cosmic nurseries. Nebula are akin to nurturing parents for stars, shaping their characteristics such as size, mass, and chemical composition. The nurturing process also extends to the formation of planetary systems, as planets often form in the disks of gas and dust that surround young stars within nebulae. The stellar nurture hypothesis challenges the traditional view of nebulae as static environments and instead presents them as dynamic, interconnected systems that actively influence the formation and evolution of stars. This theory highlights the intricate relationships between stars and their birthplaces, shedding new light on the cosmic drama of star formation. Nebula are vast clouds of gas and dust in space, and they are primarily associated with the birth of stars and planetary systems. Planets themselves do not typically form inside nebulae. Instead, planets form within the protoplanetary disks that often surround young stars. Here's a simplified explanation of the process. Nebula formation. Nebula are created from interstellar gas and dust. These materials can clump together due to gravitational forces, forming these clouds. Star formation. Inside a dense region of a nebula, gravitational forces can cause the gas and dust to collapse, leading to the formation of a new star. As the central star forms, it emits radiation and a stellar wind, which begins to clear out the immediate vicinity around it. Protoplanetary disk formation. As the central star continues to grow, a rotating disk of gas and dust, known as a protoplanetary disk, forms around it. It is within this disk that planets and other celestial objects can form. Planet formation. Dust and gas in the protoplanetary disk can collide and stick together, forming planetesimals. These planetesimals can further coalesce into planets through a process known as accretion. In some cases, these planets can become large enough to accumulate a substantial atmosphere. So planets form within the protoplanetary disks that are associated with young stars, which are often found in or near nebulae. As the star continues to evolve and clear out the surrounding material, the planets remain in orbit around the star. Therefore, while planets are not inside the nebula itself, they are intimately linked to the star-forming regions associated with nebula. There are several nebulae relatively close to Earth within our own Milky Way galaxy. Some of the most famous and easily observable nebulae from Earth include 1. Orion Nebula, Moab 42 and 43 M43. The Orion Nebula is one of the closest and most well-known nebulae to Earth. It is located in the Orion constellation and is visible to the naked eye as a faint star in the Sword of Orion. It's a stellar nursery with young stars and protoplanetary disks. 2. Lagoon Nebula. The Lagoon Nebula is another prominent nebula located in the Sagittarius constellation. It is visible to the naked eye and is known for its distinctive shape and bright central region. 3. Deagle Nebula. 16, like the Eagle Nebula. made famous by the Hubble Space Telescope's Pillars of Creation image, is another relatively close nebula. It's situated in the Serpens constellation. 4. Trifid Nebula. 20. The Trifid Nebula is located in the Sagittarius constellation and is known for its three-lobed appearance, which gives it its name. 5. Carina Nebula. This massive nebula is located in the Carina constellation and is one of the largest and brightest nebulae in the night sky. It contains a wide range of celestial objects, including young stars, star clusters, and regions of ongoing star formation. These nebulae are part of the Milky Way galaxy and are relatively close in astronomical terms, with distances measured in thousands of light years. They are often popular targets for amateur astronomers and astrophotographers due to their striking appearances and proximity to Earth.